I want to go through everything, though, that's going to be on your quiz tomorrow. So tomorrow will just be a regular quiz day. There won't be homework or anything after the quiz. It'll just be a quiz. And we'll talk more about rescheduling if you're not going to be here in a few minutes. Okay. It says that it wants me to find the degree for number 1. Okay, I don't need decimals for that. What is the degree? 8. It's the biggest exponent, and since there's only one, surprise, surprise, it's 8. What's the leading coefficient? -3. It's the big number out front that leads everything off. It's asking me for domain and range, but I'm going to need my Desmos graphing calculator to help me with that. So I'm going to move this to the forefront, and I've got -3x to the 8th. So I'm going to type in -3. I'm going to type my x, and then I need Shift 6 to get it to go up to the exponent, and then I need an 8. I don't know why, but it's giving me like mustache vibes. Like a handlebar mustache. Anybody else? I'm the only weird one? Okay, fair enough. Okay, let's zoom in on that. What is happening there? Is it just sitting at 0? What's it doing? What are you doing? It's just sitting at 0. Okay. All right, so we have got, we're kind of just sitting here at 0, but 0 is definitely the highest point. Does it hit 0? Yeah. So let's talk about the range first. Do I have any graph living up here? No. I hit 0, and then do you agree I have graph down from there? Okay. So for my range, I have a graph that's going to go from -infinity to 0, and it's going to include 0. Remember, we always go small to big. So small, and then bigger as we go to the right. So -infinity, and my graph goes up to 0, and then it stops. Now, for this graph that, again, to me kind of looks like a handlebar mustache when you zoom out, even though it's not spreading out very quickly, it's still going to spread out and hit all x values. Do you see how it's moving that way, but it's just moving real slow? But if we have till infinity, it's going to go and hit everything. So my range, or sorry, my domain is going to be all real numbers. And then we can even draw a graph for ourselves to remind ourselves what this looked like. So this is x, this is y, and here's my mustache graph. It looked like this. So it went up to here where 0, 0 was a point. And so maybe that'll help you later if you go back and look and you're trying to figure out domain and range. So again, it always goes low to high. So the smaller thing on the left to the highest on the right. So that's why I went -infinity to 0, because 0 is bigger than -infinity. Are we okay with domain, range, leading coefficient, degree for that one? Okay. Let's look at 2. It says use the graph to tell if an even or odd function happened and if it has a positive or negative leading coefficient. Okay, so this is an end behavior type of question. Even though it doesn't look like one, it's kind of like in disguise. It's wearing a mustache, it's in disguise. Okay. If you have sides that are doing opposite things, is it even or odd? What's your degree? Odd. So your degree is odd. So if your end behavior is doing opposite things, it's odd. So opposite goes along with an odd degree. The same end behavior means we have something that's even. Okay, so that could be, again, another note to write yourself as you're studying tonight. So our degree is odd. We know that much. I'll write it in the blank because that looks like it's where it's supposed to be. Zoom out just a little bit. Okay, And the leading coefficient, if it starts high and goes low, it's decreasing over time. If it's decreasing, is my leading coefficient positive or negative? Negative. So my leading coefficient is going to be negative. So if it's decreasing over time, it's negative. If it had been increasing, it would be positive. Think about even graphs. What type of coefficient do I have if this is my graph? If I'm the graph, what type of coefficient? Positive or negative? Positive. What about this one? Negative. Okay. All right, but again, you're going to check increasing or decreasing. If it decreases from left to right, again, like you read a book. You read a book from left to right. If it's decreasing, then it's negative. If it's increasing, then it's positive. Okay, let's go to the next one. Ooh, bummer. Is the next one in standard form? No. Oh, right. I'm still, no, okay. I will get used to this new cam at some point. Today is apparently not the day that happens, though. Okay, here we go. Let's put this into standard form. What term should come first? Yeah, 6x to the 4th. I agree, because it's the biggest exponent. What should come next? Negative 3x to the 3rd. What's next? Yes. And then 10x, and then 16. Okay, now that we're in standard form, what's the degree? 4. It's your biggest exponent. So your degree is 4. And again, you can write yourself little notes on here. Largest exponent. Write yourself notes to help yourself review and study this. What's the leading coefficient that leads everything off? 6. Now it says it wants me to find the value of the function when x is negative 2. What is that telling me to do with negative 2? Plug it in. So this is code for plug in negative 2. Okay, so on my calculator, I'm going to go ahead and type it in. Pinky's at home. She's taking a breather today. So negative 3. Where I'm plugging in the negative 2, I always want to plug it in a parenthesis house. So negative 2, I'm going back to the beginning, by the way. I'm using the original. So I plugged in my negative 2, and that's to the 3rd power. Plus 6x, nope, I don't want my x anymore. 6 parenthesis negative 2. To the 4th power minus 8 parenthesis negative 2 square it plus 10 parenthesis negative 2 plus 16. All right, do we see how I typed it in? Everywhere there was an x, now there's a negative 2 in a parenthesis house. Okay, I'm going to hit enter. Make sure you get the same thing I do. Make sure we're practicing. Did we get 84? Yep. Okay. So again, make sure you're doing it with me, because otherwise if you're doing it for the first time on the test, that's not always the easiest.
Does it matter if you use the original?
It doesn't. You'll get the same answer. So if you wanted to plug it into this one, that's fine too. I just started that way and I was like, oh, I guess I'm going to keep going with what they gave me originally. Yeah, either one is fine. All right, next one, we want to find the maximum, the minimum, and the zeros. Okay, so anytime it's a graph, remember you should start thinking about Desmos. So anytime I see a graph, my head goes, hey, Desmos, please.
It's off the charts.
Is it?
Yeah, it's like really big.
Ooh, okay, well, we'll get there in a minute. It doesn't look as fun as the handlebar mustache graph. I'm a little disappointed. Okay. I'm going to delete what I had in there because, well, we're doing something new. Okay. Ooh, now we're super zoomed in. See, I'm going to... Oh. Okay. Here we go. Figure this out one day. All right, 4x cubed. So I'm going to do 4x, and I'm going to hit shift 6 to the third. And then I'm going to arrow to the right. Do you see? You can barely see it. Do you see how my blinky cursor is up high, though? Arrow to the right so it'll pop back down. Minus 48x, shift 6, and then we need a 2. Plus 140x.
You hit equals.
Oh, I did hit equals. That's not what I wanted. Thank you. Good call. Plus. Okay. And kind of like Sam said, we need to zoom out, right? Okay. I'm going to zoom out that much. Okay. Do we have a min and a max? Let's find them. Okay, I'm going to go right here. If you click about where it is, it's going to put the max back in for you. So my maximum is at 1.9, comma, 120.16. All right. And then let's go down to the minimum next. My minimum lives at 6.1, comma, negative 24.16. And it looks like I have 3 zeros. You guys agree? And we can always zoom back in on the zeros if we want. And remember, you can kind of drop and drag your screen so we can get in closer to stuff. Okay, so I'm going to click on it again so they reappear. I've got a 0 at 0, 0. I'll show you my paper in just a second. I've got another 0 at 5, 0. And I've got another 0 at 7, 0. Okay, so those are my 3 zeros. So let me show you what I've been writing down off to the side here. So here are my numbers. And then like I told you, I kind of wrote myself a note to like use the decimals. All right. Now, this is my x-axis, this is my y-axis. I'm way off the charts. I'm going to count by 20s. Remember that whenever you graph, I'm going to assume you're counting by ones unless you tell me something else. Okay, so that's always going to be my assumption. So I'm going to count by 20, so this will be 20, 40, 60, 80, 100, 120. Do you see how that works out okay for me? Because then I'll be able to get up high enough. So we definitely need to count by something else. Okay. On the x-axis, though, I'm still going to count by ones, so I don't need to write anything because I'm counting by ones. You can if you want to, though, if it makes you feel better because you're like, well, I counted by something so weird on the y's, maybe I should write it. Go ahead. All right, relative maximum. We're over at positive 6.1. Oh, minimum, sorry. 1, 2, 3, 4, 5, 6. We're at 6.1 and we're down at negative 24. So this is negative 20. So negative 24 would be like here-ish. So again, we're just kind of estimating. These aren't going to be perfect. That's why they're written over here so I can tell where they truly are. So this is this point for my minimum. My maximum is at 1.9 and up at about 120. So like right here. There's my maximum. And then my zeros. I have a 0 at 0, 0, at 5, 0, and at 7, 0. And then you can look at the graph to help guide you as you draw this in. Remember, we went up, down, and then we turned and went back up again. How'd we do on that one? Is that one okay? Yes, no? Okay, flip to the back when you're ready. And remember, the quiz is going to be very similar to this, so you're not going to be thrown for a loop when you see the quiz. The quiz should very much mimic this in so many ways. All right, this one says, is it a polynomial? So this is a yes or no question. How about A? Is A a polynomial? No. Why? It's a cube root even. What about B? Yes. What about C? Yes. It's okay that there's a fraction because is there a variable in the denominator? No. Ooh, the next one's tricky. What do you think? Yeah, it's not. Remember that if you have a negative exponent, that means that that variable is really living in the denominator of the fraction. So if you have a variable in the denominator, it is not a polynomial, and having a negative exponent is the exact same thing. So we're keeping eyes out for roots and negative exponents. Okay, I'm not going to have you do number 6 on the quiz. Remember we talked about that? We're not going to do the modeling question. Let's skip down to the bottom. These are the evaluate problems. I'm going to go through. We're going to try to do these together and look for like terms. Do you see how number 7 is just subtraction? Be careful. It's not asking you to multiply. That'd be super mean, wouldn't it? If that was a multiply one. Okay. We've got 6x to the 4th plus 3x cubed minus 10x squared minus 4x plus 5. So that whole first parenthesis stays as is. This second parenthesis, all the signs are going to change because I'm subtracting everything. So minus 2x to the 4th plus 8x cubed minus 7x squared plus 9x minus 7. Whoa. Takes up the whole screen. All right, now, remember you can set them up vertically, so you could have set your like terms up above and below each other. I'm just going to go through and underline and use some different colors. You can do whatever works best for you, okay? Even on the quiz, if you're like, I want to take out all my markers, you should do that then, okay? That's fine. I'm not mad at that at all. All right, let's start with 6x to the 4th. Who is 6x to the 4th, buddy? Yeah, and make sure you underline that sign, right? Because it's not just 2x to the 4th, it's negative 2x to the 4th. Okay. Now I've got 3x cubed. Who's 3x cubed, buddy? 8x cubed. Okay. I've got negative 10x squared. Who's negative 10x squared, buddy? Yeah. Well, they're all kind of positioned nicely at least. I've got a negative 4x, and so that'll go with my 9x. And then I've got just plain old numbers left over. All right. Also, it kind of gives me like one of those Bob Ross moments where I feel like, look at all the happy colors, the happy trees. That's the other reason I like to use different colors. Just make it look more festive. All right, here we go. 6x to the 4th, take away 2x to the 4th. How many x to the 4th do I have left? 4x to the 4th. Perfect. Let's move on to the dark green. 3x to the 3rd plus 8x to the 3rd. Negative 10 minus 7 more. Negative 17x squared. Negative 4 plus 9. Negative 5x. And 5 minus 7. Oh, wait, what did I do? It is positive. Oh, sorry. 9x minus 4x. Yep, it's a positive. Thank you. 5 take away 7. Negative 2. And this would be my final answer. All right. Let's go to the next one. You try starting to multiply it out. I'm going to pull mine off the screen. So you try it, I'm going to try it, and we'll see how we do. We'll match our answers up with each other in just a second. So you're foiling. Okay, I'm going to push mine onto the screen, so don't look until you're ready. Spoiler alert, spoiler alert. How'd we do? Good? Okay. Next one. Ooh, that's small font. Okay. It's telling me to cube. What does a cube mean?
Multiply ourselves 3 times.
Yeah. All right, so I kind of think about multiplication like taking the stairs. If you're going to climb up a set of stairs or go down a set of stairs, how do you fall and hurt yourself when you take too many at a time, right? Like we need to just go up one rung at a time. So what I like to do when I've got multiple sets of parentheses is I literally cover one up because I'm only going to do 2 at a time. Like more than that, and that's how I end up at urgent care falling down the steps. All right, let's multiply 2 of them. Ready? So y times y gives me y squared. Y times 3, 3y. 3 times y, 3 times 3, 9. Okay, let's combine our like terms and make that even a little bit nicer and more compact. Y squared plus 6y plus 9. Do we feel good about that? Okay. Now we have to remember that we covered up that y plus 3. So here it comes. Here's the other y plus 3. Now I'm going to multiply by that one. So it was just hiding, now it's here. All right, my first time through, I'm going to send the y through first. So everybody is picking up an extra y. Y cubed plus 6y squared plus 9y. So everything gained a bonus y. Now everything's gaining a 3. I'm going to line them up. 3y squared, 18y, 27. All right. Do you see that y cubed doesn't have a buddy? Bummer. How many y squareds do I have total? 9. How many y's do I have total? Yep. And then I have a plus 27 on the end. And this is my final answer over here. So remember, you can use colors if you'd rather do that, or you can line them up vertically. So I kind of did one of each there so you could see the 2 different things. Yeah.
If you had it raised to the power of 4, would you just keep repeating this step?
You would, yep. Or do you see how, if it was the power of 4, do you see how we got that from squaring it? So you basically have 2 things squared. So you could basically take this and multiply it by itself. Does that make sense? I don't think I have anything that big on the quiz, but I'll look real quick and make sure that it's 3 or smaller. Okay, so what would I recommend doing to review? You can watch this video back. You can go back over the worksheet. I would make sure you review this. This is as close to the quiz as you're going to get is what's here in terms of how it's set up, in terms of the questions, in terms of everything. What do you have questions about before we talk about homework? Nothing?